Hi, everybody. I am now recording the lecture for this week, which is Digestive System 2 on your PowerPoint list on Canvas. This is actually a pretty long PowerPoint, so I'm breaking it in half. I'm going to do two shorter lectures, that's called Part 1 and Part 2, just to make it a little bit easier for you to deal with it. What I would suggest, because you can stop and start and go back and do whatever you want, listen for 15 minutes or so, then stop and work on your practice questions like we do in class. If you can be on the phone with a buddy or something like that, you can talk them over and then go back to it, or whatever you like. And if you have any questions, feel free to contact me through Canvas or email me on my SCF email. And I'll answer them. So anyway, here we go. To start off, we're talking about some of the things we talked about in the last lecture. Every part of the GI tract you go through, it does something to the food. It mixes it, it digests it, it absorbs it, and then it moves along. So we're doing something and then propelling it. Motility is movement of the digestive tract. So remember that gastric is the stomach. So gastric juice is stomach acid and other juices. And enteric refers to the intestine. Also, pancreatic refers to the pancreas, and hepatic refers to the liver. And those are the main things that are going to be operating here to get our food digested and absorbed. So we have our myenteric plexus, which controls the propulsion, the submucosal plexus, which controls secretion, and all those can be stimulated either locally by stretch, by food in the GI tract, by extrinsic nerves coming in from the outside, so you're talking about the parasympathetic nerves using acetylcholine, and also by various reflexes sending a signal outside the GI tract and coming back. We can also stimulate it by the contents of the stomach or the digestive tract, which stimulate receptors to produce some local hormone type substances that will cause things to happen. The hunger drive, as most control in our body, is controlled by the hypothalamus. And remember, it's largely driven by leptin and ghrelin. Ghrelin makes you hungry, leptin makes you feel like you're full. And so that hunger is just a desire to eat something. Appetite is what we want to eat. So we are driven to eat the things that we're used to, things that have tasted good to us. We're also driven to eat things that were in short supply during evolution, like salt and sugars, because those things we needed immediately to get immediate energy and to keep us healthy. So that's why we tend to crave salty and sweet stuff. You put food in your mouth. Mastication is the process of chewing. It's voluntary. You can chew if you want, but there's also a chewing reflex. So you can chew gum and do other stuff at the same time. The chewing reflex is interesting. If there's food pressing against the roof of your mouth and your tongue, it inhibits your jaw elevator muscles, and your mouth falls open. Once the pressure is gone, then the contraction of the masseters and so forth is initiated, and it closes. So you can be reading a book and eating, and you don't have to think about chewing. So it's both. We're breaking down the food into small enough parts that we can swallow it, making it more available to the enzymes in the mouth and in the stomach. Deglutition is swallowing. That's also a voluntary and automatic response. You can swallow if you want to, but if food reaches the back of your throat, the swallowing reflex is initiated, so food won't stop there and choke you to death. So either the gag reflex will be initiated to get rid of it, or the swallowing reflex more often is initiated and the food goes on down your throat. A blob of food is called a bolus. Anywhere in the GI tract, if it's in the intestine, to move a bolus of food along, a blob of chewed up food, it reaches the back of the throat. It starts initiating the swallowing response. You're going to have the upper esophageal sphincter is closed right now. Right now, that's preventing reflux of stuff coming up in the back of your throat, but it'll have to open when food goes down. The epiglottis is open because you're breathing. When you swallow, though, it's going to close over the glottis. It's going to close over the airway, so the food is steered down the back of your throat. So here the epiglottis has come to a close, and the food is starting to move here. The signal hits the upper esophageal sphincter, and it opens just long enough for the bolus to go through, then it closes again. Here we go. Glottis is covering the airway. Upper esophageal sphincter is still closed, but it does open to let the food move down and closes right behind it. It moves down the esophagus by peristalsis. Remember the squeeze, 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 squeeze to move things along. Upper esophageal sphincter stays closed. As the food reaches the lower esophageal sphincter, it opens and lets the food go through and closes behind it. The upper part of the esophagus is striated voluntary muscle. So food gets stuck there, you've got to swallow to make it go down. Once it gets down in the lower part of the esophagus, it is an automatic response. And so it will automatically contract as many times as it needs to move the food on down into the stomach. And this lower esophageal sphincter is where, older people especially, it becomes a little bit less effective with age, and gastric juice moves up into the end of your esophagus and starts causing heartburn or ulcers even. Lower esophageal sphincter, here it is when it's closed, there it is when it's open. So here's a summary slide. It looks long, but this describes the whole process. It moves, goes into the back of your throat, and then your sphincter, the upper esophageal sphincter relaxes. It goes down. The lower esophageal sphincter opens. That lower esophageal sphincter, by the way, in your lab manual is called the cardiac sphincter. That's actually kind of a slang term for it. Your heart is right about here, and so problems with this sphincter feel like heart problems, and so it's also called the cardiac sphincter. I call it the lower esophageal sphincter. It describes exactly where it is and what it does. Okay, so now we got the food in the stomach. It serves as a reservoir. And remember, the stomach, along with the bladder, along with your large receptive blood vessels that can hold more contents when they need to, they undergo what's called receptive relaxation, where when contents enter, the cross bridges on the muscle fibers let go and then reattach in a new alignment so that you have the opening is big enough to hold the new amount. And it keeps doing that until it runs out of room and you're full. But that allows your stomach to start off small and wind up fairly big during a meal without you filling up before you have a chance to eat your whole meal. It's a big deal. Receptive relaxation is a major factor in the operation of your stomach and your bladder. Here's your stomach. The top of the stomach is called the fundus. We'll find that's true of the uterus too. The top is the fundus. The middle is the body. Oxyntic glands make stomach acid. Okay, so the fundus, the body. Down here we have the pylorus and the pyloric sphincter, and this entryway into the pylorus is called the antrum. Your lab manual just calls the whole area the pylorus. The antrum is an important area of the pylorus. The antrum, the pylorus. The antrum has the ability to push food back in the opposite direction when it needs to be mixed some more. it needs to be broken down some more. So the antrum can do what's called retropulsion and push it backwards. So we have the antrum, and then the pylorus with the pyloric sphincter is on the end. This will open to allow tiny bits of food to move into the proximal intestine, the duodenum, in little squirts to give the intestine a chance to digest it and absorb it before you get any more moving in there. Here it is, the fundus, the body, the pyloric antrum, or the antrum of the stomach, and here's the pylorus and the pyloric sphincter. Peristalsis starts squeezing here and moves down this way to push everything down, and then squirts into the duodenum in little tiny, like 1/10 of a milliliter squirts at a time. Remember our two kinds of movement in the upper area of the GI tract. We're talking about the small intestine, enteric system, and also the stomach, the gastric system. Segmentation means just squeezing back and forth to move stuff around and mix it up really well and help break it up. So the stomach does that. When your stomach is churning, that's what it's doing. Then peristalsis squeeze in a linear direction to push the food downward to the next part. I've taken out a couple of slides. If you have the old version of this, there were a couple more of those slides that I didn't think were very helpful. You can get the newest version. I've put the newest version on Canvas now, so you probably, if you just opened it, you're looking at the new version anyway. And then remember the migrating motor complex. About every hour and a half or so, when there's no food in the stomach, the interdigestive phase, motilin will be released and increases motility of the entire GI tract, and it pushes everything on to the next part of the GI tract. It's the house sweeping effect. So it pushes the food that was hanging out in the duodenum into the jejunum, onto the ileum, from one part, so that it helps to keep the food moving along between meals. Now, the colon has a slightly different plan. It still does what you could call segmentation and peristalsis, but we have special names for segmentation and peristalsis in the colon. The colon gets, about 1 liter or so of liquid chyme every day, and only about 50 to 100 milliliters of water winds up in your final feces. That's why it's solid. It receives liquid. If that was what you pooped out, you would have diarrhea. But one of the main jobs of the colon is to squeeze out all of the water and retain the water. You're trying to retain the water, and then have a solid feces that you're able to move on out. You also absorb a few things, some of the electrolytes and things, but mostly in the colon, we're absorbing water. The segments of the colon, and here, see these guys? They look like bumps. Those are called haustra. And so haustration is what the mixing motion in the large intestine is called. The segmentation motion is accomplished by these individual haustra. So here, this guy squeezes, then this guy squeezes, this guy squeezes, this guy squeezes. So it's called haustration when you're squeezing individual haustra, essentially doing the segmentation type of thing, haustration. And then when you want to have peristalsis, instead of squeezing here, 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 and here, let's look over here. Instead of squeezing 1, 2, 3, 4, and gradually moving it across, this whole area squeezes and everything moves to here. And then this section will squeeze and it'll move everything to here. And this will squeeze, it'll move everything to here. It's called mass movements. So the peristaltic action in the large intestine is called mass movements. So you tend to move big blocks of feces at a time from one part of the large intestine to the other. Here we have this, the whole thing is the colon, the large intestine. Here we have the small intestine enters the large intestine at the cecum. We talked about this before, and we'll do it in labs too. At the cecum, here's your appendix hanging off the bottom of the cecum. You have the ascending colon, the transverse colon, the descending colon, the sigmoid colon, which is shaped like an S. Then you have the rectum and the anus. So those are the parts of the GI tract. I mean, of the large intestine. Transit time typically is about 48 hours. So the food that you're pooping out today usually is what you ate 2 days ago. You generally defecate every day, but it's, what comes out is taken 2 days to completely digest and absorb and get the water out of it and all that so that it comes out about right. So transit time is the time it's taking for 3 minutes to 30 minutes to an hour. And you can see that this moves in chunks. So it's mass movement from here to here to here and then finally out. Defecation is a reflex. Usually the mass movement doesn't have any feces in the rectum. The rectum is that last vertical part before the anus. Once the descending colon does a mass movement and pushes feces into the rectum, it initiates the defecation reflex. And the desire to defecate immediately is apparent to you. Now, as we'll see in the urinary tract, you have an internal sphincter and an external sphincter. The internal sphincter is autonomically controlled. It will just open as soon as there's feces in there and allow defecation to occur. The external anal sphincter is voluntary muscle, and so you can control it for a while until you get a chance to go to the bathroom. So it wraps around the internal sphincter, slightly distal, so it can control after the internal sphincter relaxes. But it is something that you can contract on your own to control defecation. The other kind of propulsion that we have segmentation and peristalsis in the small intestine. We have hostration and mass movements in the large intestine or colon. But the other kind of propulsion we can have is vomiting. And my co-teacher and I used to always joke, whichever of us got to do the defecation and vomiting lecture. Vomiting happens when your GI tract is stimulated to think you have something dangerous to you in there. So if you eat bad food, if you eat something that tastes so bad or stimulates you so badly that your body says you got to get rid of it, you'll vomit. You also will vomit if you get a virus that stimulates those same vomiting centers. It tricks your body into thinking there's something in your stomach that has to go, and it makes you vomit. It's not like it's particularly useful to vomit if you have the flu, but you might. Vomiting is you get rid of the stomach and the proximal duodenal contents, because those are the ones that are signaling that something is wrong, and of course it comes out of your mouth. Nausea, tachycardia, dizziness, you kind of turn pale, sweating, really unpleasant early symptoms before you wind up vomiting. The vomiting center is in the medulla, and it is stimulated by a variety of things like sickness or whatever. Stimuli, if your stomach is too full, if you overate, it makes you feel like you need to throw up. Tickling the back of your throat, which indicates the gag reflex, also can cause you to throw up, to try to clear out your back of your throat before you choke to death. A kick to the groin, especially in guys. And interestingly, motion sickness has a tendency to stimulate those same vomiting centers. Again, it's not particularly useful to throw up when you're on a boat, but you can't help it. That's, your body wasn't really designed to be on boats, so it's not very good at handling that. The vomiting reflex, reverse peristalsis from the middle of your small intestine upward. You relax the pyloric sphincter so duodenal contents can move back up into the stomach. A forced inspiration against a closed glottis to try to decrease pressure and pull it up. Your abdomen contracts. The lower esophageal sphincter relaxes. The upper esophageal sphincter relaxes eventually. If the upper esophageal sphincter, which is the last to be signaled, stays contracted at first, you retch. And in most cases, you'll retch a number of times before you finally get to throw up. This is one of the most uncomfortable parts of throwing up, is when you feel like you have to, but you can't. The upper esophageal sphincter is keeping the contents in there until it's really sure that you need to throw up. If it opens, then you project the vomitus outward. You close the epiglottis over the glottis so that you don't suck in the vomit into your lungs and kill you, choke you, or give you pneumonia. And if you vomit without retching first, it catches everybody by surprise, and this is called projectile vomiting. Projectile vomiting is if there's no retching going on at first, if just suddenly you vomit. And this is what they're always showing on, the ER shows and stuff on TV. If they bring somebody in and suddenly they vomit all over everybody, that's projectile vomiting. Okay, I'm going to stop this lecture right now, this half of the lecture, and we'll take up the GI secretions in a second section of this same first lecture.